Back in October, we ran a CTF inside the MyDFIR SOC community, and I wanted to walk you through it because I think that it will help you with building out your own investigative methodology. As an FYI, we do run a new CTF every single month. So if you want to actually get your hands dirty and practice, I'll leave a link in the description down below. Also, I am currently working on a new course focused on DFIR. We're talking about Windows, Linux, network, cloud, and memory forensics. It is going to be a big one. Once it is released, it'll only be available inside the community until further notice. More details on that very soon. All right, let's get right into it. On October 12, 2025, we released the first official Capture the Flag event specifically for our community members. And this was the scenario. It says, "Team, we have a major situation. I've been informed that several of our most sensitive files have been discovered on the public internet. Our intellectual property, customer data, and strategic plans are potentially compromised. I need the Moss Cyber Defense SOC to immediately investigate this breach. We need to know, how did this happen? What was the attack vector? Who is responsible? And what is the full extent of the damage? Time is of the essence. Every second counts." And this was sent from our client, who is the CEO of Maple Tax Solution, Zach Balrog. Now, for this particular CTF, what you'll be doing is that you'll be uncovering 24 total flags. And I structured this in a way where it's split between two tracks. So you have 12 flags under the beginner level, and then you have 12 flags for the advanced level. And this isn't just a CTF where you find the flags and call it a day. Instead, you actually need to not only find the flags, but you must submit a final investigation report. Because in the real world environment, you aren't just collecting flags, you are actually building up a report and sending that over to a client. So I want to make sure that this CTF event not only captures the fun of it, but also adds some kind of realism to it as well. Within the CTF, there is going to be a scenario overview and also an investigation playbook along with a KQL hunting guide. And this was created by Mohammed, aka Sank Logic, so thank you for that. And for the rules and expectations, of course, gotta add some of that just to avoid some naughty behavior. And there is going to also be prizes for the first, second, and third place winners. But most importantly, you can share your final investigation report to LinkedIn or add it onto your portfolio. And I think that is honestly the biggest win here. It's not about the gift cards, it's not about the prizes, but it's about learning how to investigate and build up that report. Now, I wanted to mention this because if this is your first time hearing about the CTF and you missed this one, don't worry, we are going to be doing this monthly. And yes, that means monthly prizes as well as an opportunity to build up a bunch of investigation reports so you can get that repetition in and build that skill set. Without further ado, let's head straight into the CTF. So we have the beginner track right here at the top, and then we have the advanced flag at the bottom and also a bonus. So let's start off with the beginner. And actually, before we go into this, I am going to open up a notepad so we can take some notes. And the first flag says, identify the attacker IP. Please use the time frame between October 7th at 4 a.m. to 10 a.m. UTC. And the question here is, someone gained unauthorized access to MTS-contractor PC1 via RDP. What is the attacker's IP address? The way I structured it is I created some hints for members just in case that you get stuck. And if we click into it, we can see that, hey, to find this answer, you want to utilize the security event and or the device logon events table. Then we want to filter for the time of interest. Look for the successful logons, which is event ID 4624 if we are using the security event table. And then we want to see which public IP shows up and then perform some OSINT. So why don't we do that? I'll head over to my XDR portal, go into investigation and response under hunting and advanced hunting. In this case, I am going to use the security event table, and I am going to filter between the time range of 2025, October 7th, and it mentioned 4 a.m. up until 2025, October 7th at 10 a.m., just like so. If we go back over to our CTF here, it specifically mentioned that someone gained unauthorized access to MTS contractor PC1. So I will go ahead and filter directly for this computer by putting in where computer, and I'll just say contained for now and say contractor PC1 just to make sure we get some hits, and we do. Perfect. Looking at the field value under computer, it is MTS-contractor PC1. So rather than saying contains, I am going to say equals MTS-contractor PC1. Now I am also going to filter where the event ID equals 4624, which is account successfully logged on. And we get 5 hits. Now if I scroll over, I can see that there is an account of contractor and also an account of administrator. So why don't we scroll over and see what we can find for these particular columns. Now there is an IP address of 142.90.213.242 and an IP address of 81.141.200.165. So I am going to copy this, go into abuse IPDB, and I'll paste that in there. We can see that the country is from Canada and Toronto, Ontario. The key here is context. For this particular client, Maple Tax Solutions, they are actually located in Toronto, Ontario. What this tells me is that this is likely legitimate. But what if we take a look at the other IP? If we paste that one in, we can see that this is from the UK, and that is very suspicious because, again, Maple Tax Solutions is located in Toronto, Ontario, Canada, and they don't do any business in UK. What that tells me is that this particular IP address is likely our attacker. So I'm going to go ahead and paste in this flag and hit submit. And that is correct. Now, if you were curious what hint number 2 was, we can go ahead and expand that. And the way I structured it is that I provide you with a KQL query, and I'll copy this to explain what I am doing in this query. All right, starting with the first one, we got our security event. This is our table. And then we are filtering between the time of interest, where the event ID again is 4624, which is account successfully logged on. I am doing an additional filter where it says where not IPv4 is in any range, and I provide the private IP ranges. So I'm essentially filtering out any private IPs. And then I have another filter where the computer equals, and the squiggly line here, that just simply means ignore case sensitivity. And I list out the MTS-contractor PC1. And then finally, I have the summarized count by IP address and computer. This is going to group the events based off of the IP address and computer. If I go ahead and run that, we get a query cannot be parsed because of my year, month, and day. So let me go ahead and change that by just copying this, and let's paste that in there. And there you go. So we get 2 hits, 2 IPs, which is what we identified earlier. Now I am going to take note of this. So our first login attempt from this UK address created a logon type 3, which is a network logon type. However, if we look at our flag once again, it says that someone gained unauthorized access to MTS contractor PC1 via RDP. And via RDP is actually logon type 10 and or 7. Logon type 10 is remote interactive, and this is our first observed event for an RDP login. So I am going to copy the time generated, and we'll begin creating a timeline. That way we can follow the chain of events. The IP address of 81.141.200.165 successfully authenticated via RDP into contractor PC1. And before we move on to the next flag, taking a look at the tactic, this right here is the initial access tactic. So how did they get in? And then if we look at the compromised account, which is the next flag, the question says, what was the account name that the attacker used to successfully log onto MTS contractor PC1? And again, the tactic is the same, initial access. Now, if we go back over to our advanced hunting, under the account field, we can see that the user is actually administrator. So I'll copy that and let's paste that in here. Beautiful. The next one is abused built-in Windows tool. This time around, the tactic is execution and no longer initial access. And before we move on, let me just go ahead and put that in, initial access. Let's see. On MTS-contractor PC1, the attacker leveraged a built-in Windows executable to covertly download a malicious file from the internet known as using a living off the land binary, aka lolbin. Which native Windows executable did the attacker abuse to download a file? And I provide some learning material here for the members to take a look at to identify any kind of lolbins. Now, if we take a look at hint number 1, it says use the device process events and device network events table, filter to the time window of the activity, and focus on the child process. Okay, I am going to use the device process events. Let's copy our date and time. And I'm going to say where device name contains contractor PC1. So in total, we have 549 events. That is quite a bit. So what we want to do here is try to narrow it down even more. How do we do that? Well, right now, if you take a look at the time, it is currently at October 7th at 4 a.m. But when did the attacker log in? And that is why we create a timeline. So the attacker logged in via RDP at 4:13:10. And what I'm trying to identify here is what happened after the successful login. So rather than starting at 4 a.m., why don't we start at 4:13? And now we have 388 events, which is still quite a bit, but it's definitely not 500. If we go back over to the CTF and click inside of the resource, we can learn just a little bit more about what a lolbin is. So a lolbin is a legitimate system file or script that was originally developed for administrative or diagnostic purposes. Here are some of the lolbins that are used most frequently. So we have PowerShell.exe, WMIC, Mishta, RunDLL32, and certutil.exe. Now, these are just some of the most frequently used, and these aren't all of them. So do keep that in mind. However, what we can do is search for the first one, which is PowerShell.exe. And I can do this by saying where file name contains, and I'll just say PowerShell. Now we have 34 items. What we are trying to do is narrow down the events. That way it is more realistic for us to identify suspicious activity. Because if we went ahead and just looked at 300 or even 500 events, that could take a long time. And not only that, it could be quite overwhelming. With that being said, we can now begin our analysis. I'm going to scroll over to the right just to see some process command lines and also the child processes. And you know what? Actually, I am just going to project this. So I'm going to say project time generated, process command line, and I'm going to put in initiating process file name, initiating process command line, and I think that is it. So we do see some pretty interesting activity here. Starting around 6:21 a.m. There is a interesting process command line referencing an executable under the C user's public directory. Again, this happened around 6:21 a.m. and that is about 2 hours upon successful login. What happened after the account logged in? Right now, I want to figure that out. The 6:21 a.m. is definitely something to note. So I'll go ahead and copy that and I'll say October 7th, 2025, 6:21:01 a.m. And I'll just paste that in here. But what happened in these 2 hours? That is what I want to figure out. Now, instead of looking at device process events, let's shift our focus onto device network events and see what we can find there. Copy the date and time range, and let's do the device name as well, and also the PowerShell. Now, we do get a red line under the file name, and that is because device network events doesn't have a field name of file name. Instead, we can utilize the initiating process file name and then run that. Around 4:18:54, so about 5 minutes, give or take, the PowerShell binary initiated an outbound connection over towards the IP of 78.141.234.86 on port 1337. And if we expand the remote URL, we could see that it pulled out a PowerShell script, starting with KB, ending in 44. That is something to note. I'll remove this 2 hours, and then let's say PowerShell established outbound connection to, what was the IP again? to this IP and downloaded this PowerShell script. Beautiful. Now we can start to see, once the attacker authenticated via RDP, they opened up PowerShell and established an outbound connection over to this IP and downloaded this PowerShell script. Heading back over to our CTF, which native Windows executable did the attacker abuse to download a file? This is going to be PowerShell.exe. For the domain of interest, what is the domain/IP of the attacker's command and control server? That we just identified, which is 78.141.234.86. And out of curiosity, I want to throw this into Abuse IPDB and take a look. We can see it is from the UK, and the ISP is the Constant Company. All right, let's copy that, submit, and that is correct. Heading over to the next one. This tactic is command and control. Suspicious script downloaded. What script was downloaded from the attacker's command and control server using the built-in Windows tool that we identified? Well, we saw this via here. They downloaded the PowerShell script. Now on to our tactic of discovery. Attackers often run small commands to learn about the computer before doing anything else. Now, not only the computer, but more so the environment itself. And that step is called discovery. Your job is to find the discovery command that the attacker executed on MTS-contractor PC1 to obtain information about the system. And I also provided a reference here for folks to learn more about the discovery commands. So if we take a look into that, and on this site, we can see that there are multiple commands such as hostname, ipconfig, net, quuser, quwinsta, etc. And looking at the first paragraph, it mentions when entering on a host for the first time, an adversary may try to discover information about the host. And there are several built-in Windows commands that can be used to learn just that. And those commands are the commands that I just went over. Now, what we can do with this is copy all of these commands, head over to Advanced Hunting, and then we are going to search inside the device process events. And from here, actually, you know what? Let me use the previous device process since we already have our query built out. So this one right here. What I'll do is change the file name to process command line, and I'll say in. And actually, instead of saying in, I'm going to say has any. And then I put in the host name, IP config, and everything else. I did remove the SC with flags and only put in the SC. And let's see what we can find. And we do have quite a bit of events. There are 20 events in total. If we look at the time generated, around 4:13, there was an SC, but it was start push to install login. And if we go back over to the discovery site that I listed, it mentioned that SC with flags of query, query EX, and QC. And looking at this process command line, you don't see any of that. What that tells me is that I can go ahead and ignore these two rows, but then we get into the third one where it says, who am I? And then hostname, system info, net.exe, and additional interesting discovery commands. Now, which one are we actually looking for? Well, if we look at the question itself or our objective, it says your job is to find the discovery command that the attacker executed to obtain information about the system. Information about the system. And that is key. So if we look at our advanced hunting, we have who am I, hostname, system info, net, and etc. So the one that we're interested in the most is system info. Why? Because this particular command extracts information about the system itself. And that is what the flag is looking for. Who am I simply tells you who the user is. Actually, you know what? Rather than telling you, why don't I show you? So who am I? This tells you the computer and the username. The other one was hostname. This tells me the computer. And then finally, we had system info. And this is just grabbing all of the information regarding the system itself. Pretty cool, right? So over to my flag, I am going to say systeminfo.exe. And when did this start? This started at 6:01:15. To be accurate, the system info started at 6:07:19. However, the discovery phase started around 6:01. So I'm going to put that down. Around 6:01, there was discovery, starting with who am I? The next flag is find the persistence. It says the attacker made changes to the registry on MTS Contractor PC1 to maintain a lol bin process that you identified earlier. What we identified earlier was PowerShell. What is the registry value name that were modified? Here are some common persistence mechanisms, and I provide another link. So we go in there, scrolling down, it provides us information about what is persistence and some of the common locations that a lot of attackers use to maintain persistence within the registry. And as we can see here, registry run keys. So we do see the current user, which has the run and run once. For the local machine, same thing, run and run once. And right here, there's another one. Another common location is the startup folders. Then we have scheduled task, Windows service registry, boot execute key, and just a bunch others here. But if we go back over to the flag, it's specifically asking us for the registry value name. And to find information about the registry, we can actually use the device table name called device registry events. So I'll type in device registry events, paste in the time and the computer of interest. And wow, we have 796 events. That is quite a bit. So let's narrow this down by filtering for the action type. As you can see, there's currently registry key created, registry value set, and what else here? From what it looks like, it is only those two. But to make sure, what we can do is summarize count by action type. And we actually have 4 different action types. We have registry key created, value set, value deleted, and key deleted. Again, looking at the flag, what is the registry value name that were modified? Instead of created, it is likely that we're looking for value set. So I'll say where action type equals registry value set. And we have 308 events. So I am going to comment out the summarize count by. And we are trying to identify anything that contains our PowerShell lol bin that we identified earlier. And that would likely be located under the registry value data. So I am going to filter where registry value data contains, and we'll type in PowerShell. There you go. So around 6:16:36, there was a registry key that was modified. And this registry value name is called OneDrive Standalone. And what this registry key does, it will run our PowerShell.exe and start the process of Microsoft Edge update.exe. And this particular file is stored under the C:users public directory. Copy out this time, and this started around 6:16. And if we look at the registry key, this is located under the registry run key. This is our attacker's persistence. I'll type in created persistence, and let's say registry run key. So the value name is OneDrive Standalone, and it executes this command line. I'm going to copy the value name, and let's paste that in here. The next one is Microsoft Defender exclusion. This tactic is defense evasion. It says Microsoft Defender normally scans files, folders, and processes to stop malware. How many unique processes were excluded from Defender? Now, this one can be a bit interesting because depending on what is being excluded, the registry path will be different. In this case, it is specifically asking for unique processes. What we can do is perform a search, Defender process exclusions. And if we take a look at the blog post created by Huntress, scrolling down, we can see the different exclusion types. We have the process, path, extension, and IP address. Continue on to scroll down, we eventually can see the registry query value. So what this tells us is that whenever an exclusion happens, then the registry is modified to reflect that change. Take a look at the file path here. We can see that the exclusion is for a path and not a process. But do take note of the file path. It is HKLM software, Microsoft Windows Defender exclusions, and there's another one called HKLM software policies, Microsoft Windows Defender exclusions. So there are 2 different file paths that we could take a look at to identify any of the processes that were excluded. And if we continue to scroll down, here is the registry path that I just referenced. So there is the exclusion, and then there is also the policies exclusion. Learning that, we can now head over to our XDR, and under the device registry events, maybe we can search where the registry key, so this one right here, contains Windows Defender. Type in registry key contains, let's do Windows Defender. And there are 28 items. Now the flag is looking for unique processes. Maybe I might be able to filter for anything that says process. If I expand the registry key, we can see paths, and then we can actually see processes. So that's pretty cool. Now I'm going to say where registry key contains Windows Defender and registry key contains, let's do processes. And we get a total of 8 items. And if we look under the column name of registry value name, we can see that there is 1, 2, 3, 4, 5, 6, 7, 8 unique processes. And that means the answer for this flag is 8. Looking at the dumped credentials, we have our tactic of credential access. And actually, before I do that, let's go back over to our XDR. And the exclusions started around 419.01. Looking at our timeline, 419.01, Defender processes excluded. I'll say 7 processes excluded because around 621, that is when reg served 32 was excluded. I'll copy that out and let's put this in here. Defender reg serve excluded. Cool. All right. On to dumped credentials. Our tactic is credential access. The attacker ran a program that tried to read sensitive information from the computer's memory. This is how attackers can capture account passwords or hashes. What is the exact file name of the program that accessed system memory to steal credentials on MTS Contractor PC1? Well, what if we take a look at the hint? And it says, use the device process events, filter the time window, and then focus on the process command line. Scrolling up over to device process events, this is our timeline of interest. I am going to remove the process command line, and I will keep the project where it shows the time generated, process command line, initiating process, and initiating process command line. And now we have a nice table. If I go back over to my timeline here, what I'm interested in is what happened after 419. So what happened after Defender excluded those processes? So I'll scroll all the way down until 419, and this is it. Ooh, there is an activity here where the firewall was actually turned off. This occurred at 419.01. So the same time when Defender excluded the process. That is good to know. Let's continue on. And scrolling down, we don't really see too much information regarding credential theft. So instead, I am going to take a look at another table called device events. And this table is essentially a catch-all. So any kind of interesting events that might not fall under the device process events or device network events, Microsoft has this nice table to just dump everything in there. At least that's how I see it. So I am going to copy those 2 filters, paste that in here, and do the same check that I did previously. So let's scroll down all the way to 419, and we do see a couple of PowerShell commands. So if I scroll all the way to the right, or actually, if I just click on the event over to the right, I can scroll down and see what happens here. And yeah, we can see that PowerShell is trying to disable some functionality for our Microsoft Defender. And this is all under the field name of additional fields. What I'll do is project, time generated, and let's do additional fields, along with the initiating file name. And you know what? Let's do action type, just in case. All right, now it's a lot easier to see. We can follow the chain of events. Scrolling down, we can identify the exclusion paths that the attacker had created, and also the exclusion extensions. So .ps1, .exe, there is C Windows Temp, C Users. And then finally, around 628.25, look at that. Description, Defender detected hack tool Mimikatz. mimikatz.exe. And they downloaded this around, or at least they attempted to download this around 6/27/22. And they started the process around 6/27/27. That's pretty cool. So I am going to copy this here, 6/27/22. And Mimikatz was downloaded. And for those that don't know, Mimikatz is an open source application that allows users to view and save authentication credentials. And if we look at our question, it is asking, what is the exact file name of the program that accessed system memory to steal credentials? And essentially, Mimikatz is the executable that we're looking for. So I'll type that in, mimikatz.exe. That is correct. The next one is additional asset compromised. This tactic is lateral movement. After the attacker obtained credentials, they accessed another asset. What is the name of that asset? Well, there are a couple of ways that we can do this. First and foremost, we could actually utilize the security event, which is at the very top. So this one right here. And if I run this again, copy the attacker IP address, I'll say where IP address equals. Let's see if there's any other computers that this IP address logged into. And it doesn't appear to be so. It only appears to be this contractor PC1. However, if we take a look at the administrator instead, so I'll say where account ends with administrator. Again, we get contractor PC1. All right, what if we try device logon events? Paste that in here, and I'm going to change this to, let's go ahead and comment that out. And let's see what we can find. So this is at 4 a.m. And if we think about this, once the attacker received credentials, they compromised an additional asset. So that would likely mean that they logged in from contractor PC1 to the additional asset. In other words, the IP address should be sourcing from the contractor PC1. What we can do to find the IP address for our MTS contractor PC1 is use a table called device network info, where device name contains MTS-contractor PC1. And let's do for the last 30 days. And here we go. Looking at the IP address, it is this right here. So our internal private IP address for our MTS contractor PC1 machine is 192.168.10.11. What we're trying to identify now is lateral movement. In other words, we're looking for a successful login that is sourcing from this IP and or the computer of MTS contractor PC1 within our time of interest. And if we can identify a successful login towards a different machine, then we can infer that that machine is likely compromised. Now that we have the IP address, let's go back over to our device login events. And I am going to say where remote IP equals the IP address of contractor PC1. And we don't see anything here. Okay, what about security event? So if I comment these out and then say where IP address equals, do we see anything here? And we do not. Let me go ahead and comment out the IP address. And let's just do this. Where time generated is between our time of interest, and we are looking for successful logins. In total, we have about 39 items. Now, let me go ahead and summarize, count, and I'll say by IP address and computer. Taking a look here, we still only see our contractor PC1 with our public IP address of the one that we identified earlier. So instead, let's take a look at the device login events next. And let's add in a filter where it says where account name does not end with the dollar symbol, because I'm not interested in any computer/system accounts. And we have 151 events. Now, we do know that the account of administrator was compromised. So what if we take a look at where the account name equals administrator? Now we have 98 events. So we're slowly getting there. What if I narrow down the focus of only RDP logins? So I'll say where logon type equals remote interactive. Now we have 7 events. We can start to see the chain of events. So for 13:10 a.m., we can see that administrator RDP'd into our MTS contractor PC1. And then around 7:02:33 a.m., administrator RDP'd into our MTS-DC computer. Interesting. Where did this come from? And look at that. The IP address of 74.249.82.128. What is this IP address? We can see that, hey, it's actually coming from Microsoft. Does that mean it's legitimate? Not really. It just means that we got to do additional investigation. So let's go back over to advanced hunting here and do keep note of the time. So it is at 7:02:33, and let's put that into our notes. So administrator logged into MTS-DC from, what was the IP? 74.249, and this was Microsoft. Now, to determine whether or not this was actually a malicious login, what we can do is look at the events that occurred after the login. Hey, Future Steven here. I just wanted to say, while I was editing this video, I completely forgot about this technique. And I wanted to stress the importance of taking breaks, especially when you're doing some analysis for quite some time, because you can and will miss some things, which I clearly did in our video. But later on in the video, you'll see how I came to a conclusion that this was actually an unauthorized login. However, I did want to show you this technique on how the threat actor moved laterally within the environment, and everything will start to make sense, I promise. With that being said, the first thing we wanted to do here is filter on the time of interest. If you recall, our timestamp was around 7:02:33. So this was when our administrator logged in to our DC from the Microsoft public IP address. And if we take a look at the device process events, looking specifically for our contractor PC1, and then sorting the time in ascending order, we can now follow the chain of events. Again, the successful login was at 7:02:33. So if we look at the time generated at 7:02:24, look at that. We see a mstsc.exe. You might be asking, what is that? Well, that is a Microsoft Terminal Service Client, essentially RDP. And if you take a look at the file name or process right above it, we do see a cmdkey.exe. And if we focus on the command line itself, let me go ahead and expand that. We can see that it says generic and the public IP address of the domain controller. This is incredibly important because if they are specifying the public IP address and they successfully log in, then on the domain controller, it will then log the public IP of the source. We could also see the user of administrator and the password as well. As an FYI, cmdkey.exe is used to store credentials within your computer. And essentially what this threat actor is doing is storing the credentials of administrator with the password or the IP of our MTS-DC computer. That way, when they execute mstsc.exe, that way when they run RDP, let me just scroll over to the right real quick, they could just put in the public IP address of the domain controller and it wouldn't ask for credentials. Why? Because of the previous step. They saved the credentials by using cmdkey.exe. And that will explain why we see a public IP address of 74.249.82.128. Because that is actually the public IP of our contractor PC1 machine. And you might be wondering, well, how do I know that for sure? Is it possible to query that? And the answer is yes. We can actually find this under the table of device info. So I'll just pipe this into device name, and we'll just say contains contractor PC1, and take a look at that. Under the public IP column, we have 74.249.82.128. Going back over to the timeline, 74.249.82.128. So if we were to update this timeline, on October 7th, 2025, 7:02:23, which was 10 seconds before the successful login, the attacker saved credentials via cmdkey.exe for MTS-DC. And then afterwards, what time was this? This was at 7:02:24. So October 7th, 2025, 7:02:24 a.m. The attacker ran mstsc.exe pointing towards the public IP of MTS-DC. And then about 9 seconds later, the DC registered that the administrator had logged in from the public IP address of contractor PC1. And that is how the threat actor moved laterally. But again, while I was analyzing this, I completely forgot about this, and that was my bad. So the moral of the story is make sure you take breaks, otherwise you might miss key important information like I did. Let's go back to the video. For example, I'm going to search under the device process events and changing the time. I'm going to say 7:02 because that is when the administrator logged in. And this time, where device name contains MTS-DC. And if I scroll down from here, we have server manager. Yeah, these processes, they don't really stand out. But, ooh, what is this? PowerShell.exe, command import module active directory. And this occurred at 7:04:29. And then around 7:07, we can see that the PowerShell that we just noted here ran the Microsoft Edge update.exe, which we identified earlier on contractor PC1. Then we get service host underscore update.exe, QuickBooks underscore sync.exe, and also a modification for the firewall where it is turned off. And this is all generated from that one PowerShell session. So I am going to say that it is very likely the login that occurred around 7 o'clock is malicious or unauthorized. And what that means is that our flag is likely MTS-DC because that is the additional asset that the attacker had compromised. Taking a look at the next flag, it says sensitive documents viewed. This is the tactic of collection. After moving laterally, the attacker opened sensitive company files. What is the file name of the last file that they opened? Okay, this one's quite interesting because this actually happens quite often. What we can do to identify this is to look for any processes that are known to view documents. For example, we can look for word.exe, we can look for notepad.exe, maybe even wordpad.exe, etc. And if we expand the hint, it mentions use the device process events, search for processes under the column name of file name that could be used to view documents. I am going to keep the device name of MTS-DC, and let's search for where the process command line has Word, Notepad, what else? Maybe Adobe, some kind of PDF. Let's just do WordPad, and that'll be enough for now. We have a total of 8 events following the chain of events here. It is sorted correctly, which is great. And what were they looking for? They were looking for the last file that they opened. The last file that they opened is this one right here, bankroutingnumbers.txt. I'll copy that and let's paste that in here. Now let's add some notes. So around 7:17:54, the attacker viewed documents. I'm going to say under this file path. And then around 8 o'clock, attacker viewed documents under C:finance reports. Alrighty. Archive used for exfiltration. This is the tactic of collection. The attacker bundled several documents into a single archive. For example, a .zip or a .rar. What is the full file path, including the name of that archive file? Taking a look at our hint, it says use the device events, okay, and search for the file extensions typically associated with compression. So .zip or .rar, and we'll use the device file events. I don't think I have a table. Yeah, okay, I don't have a table for device file events yet. Let's create a new one, and I'll copy the device name and our time generated. So just like so. And then let's search up where file name ends with. Let's try .zip for now. And yay, we do have something. At 7:34:36, there is VM agent logs, but the folder path is d collect guest logs. So this is actually Azure doing its thing. So we can go ahead and ignore that. But at 8:10:59, there is a file that was created called backup.zip. And this is the folder path. It's under C program data, Microsoft, crypto, RSA, backup.zip. And that is our answer. It is asking for the full file path, including the name. Let me go ahead and put that into my notes. Attacker created a zip file called backup.zip. And let's paste in the full directory. There you go. And finally, we have our last beginner flag, cloud service for exfiltration. After archiving the files, the attacker didn't keep them on the local machine. Instead, they uploaded the stolen data to a cloud storage service. Which cloud service did the attacker use to upload the data? So in this case, we are likely interested in the device network events table, because this will allow us to see what domain did the attacker use or access to exfiltrate the data. And let's keep in mind that the backup.zip file was created at 8:10:59. So I am going to change my date time, and under device network events, I'll change this to 8:10, where the device name is MTS-DC, and I am going to filter out the initiating process file name. The goal here is to identify any kind of cloud service that can be used to upload files to. And immediately around 8:11:01, we can see that there is a remote URL towards file.io. Now, what is file.io? It is a super simple file sharing service. Now, did they upload any data? Well, that is kind of difficult to identify without actual network related telemetry. But what we can infer is that yes, it is likely that they did upload data. Over to my flag, I am going to type in www.file.io and submit. And that is correct. And just like that, we are finished with the beginner track. The next track is the advanced track. And the way I structured this one is that all of the hints now cost points. So every time you do a hint, it will cost you 25 points. And the hints are more so generic or vague. They're not incredibly specific compared to the beginner hints, which is intentional. Before we move on, let's make sure that we add this into our timeline. I'll say attacker likely exfiltrated data via file.io. Now, let's take a look at our advanced flags. The attacker wanted to work without being detected on MTS Contractor PC1. So they tampered with Windows Defender by changing registry settings, and we actually saw this previously. They modified multiple registry values to disable different protection features. How many distinct registry value names were modified by the attacker in the policy-controlled Windows Defender registry key? The hint here is the policy-controlled. So if we go back over to our Huntress blog, we're looking for the registry keys that were modified under this policy path. And if we go back over to our device registry events, where it is action type equals registry value set, instead of saying processes, what if I say policy? Does that do anything? That does not do anything. Okay. Oh, actually, it is policies like that. Okay, there you go. So we have 5 items, but are they unique? That is the question. So there is 1, 2, 3, and 4. This one right here is set to 0. What that tells me is that Defender was like, hey, I don't like this activity. Let me revert it back. But what the attacker did disable was 1, 2, 3, 4 registry value keys. And if we look over to the initiating process account name, we can see that it's done by administrator, whereas the last one was done by system, which again gives me a little bit more confidence that Microsoft Defender was just like, hey, let's switch this back to 0. And you know what? Taking a look at the time, yeah, 7:10. So the other registry values were modified around 6 o'clock up until 6:21. And then at 7:10, one of the settings reverted back. So this answer right here is 4. Breaking down the walls, after disabling Windows Defender, the attacker needed to open network access by turning off another critical security control. They used a built-in Windows command line tool to completely disable protection across all profiles. Find the exact command line, including the extension the attacker used to disable the Windows firewall. And we actually took note of this because we came across it while taking a look at our PowerShell. Go ahead and paste that in, and there you go. Covering their tracks. With defenses disabled, the attacker wanted to work in the shadows. They attempted to stop a critical Windows service that records system activity, essentially trying to blind security monitoring. Identify the exact name of the service that the attacker tried to stop. Ooh, there's one solve. Who did this? Sal. Great job, Sal. That's amazing. To find our service disabled events, you want to take a look into the device event table. So this one right here. And what we can do is create a summarize, and I'll just say count by, type in action type. And if we take a look under the action type, scrolling down, we can see some of the available options that we can use. And there is an action type called PowerShell command that we saw earlier. So I am going to actually use this and say where action type equals PowerShell command. Now let's go ahead and comment out the summarize. Now under the additional fields, let's say where additional fields contains anything with service. And we do get 3 events. And take a look at the last event. It says command stop service. The stop service name is event log. And this right here is the exact name of the service that the attacker disabled, or at least tried to stop. On to the next one. After disabling security controls on MTS Contractor PC1, the attacker established command and control communication by downloading a malicious payload from an external server on a non-standard port. To avoid detection by network monitoring tools, they disguised their HTTP traffic using a user agent string that mimics legitimate Windows system activity. Identify the exact user agent string the attacker used for this download. The hint here is user agent strings. So where can we find that in our tables? Well, in this case, I believe device network events can contain user agents. Just to make sure, let's double check. So if I click on the first event from the top, do we see any user agent? And we do not. Keep in mind that that is the event of connection success. Now, there are a lot of other action types available for us. What I can do instead to really understand what kind of columns exist is click on the 3 dots at the top, go into schema reference, and then let's search up device, network, events. This one right here. And let's see what is available. So under columns, we have timestamp, device ID, protocol, anything with user agent. And there doesn't appear to be any kind of field name that contains user agent unless it is under additional fields. What we can do is type in where additional fields contains, let's just say user for now. And instead of looking at the DC, we want to look for the contractor PC1. I'm going to close this out and do keep in mind of the time. The time right now is at 8:10. We want to go back over to, what was it, 4? Yeah, 4 a.m. Well, 4:13. Okay, so we do get 10 events. Under the additional fields, we have status code, URI, and user agent. Perfect. Okay, so we can say where additional fields dot user underscore agent. Actually, does that work? Just to make sure, I'm going to expand additional fields here. Right click the field value for the user agent and then say include this user agent. Okay, and now it automatically adds this particular query. So I'll go ahead and cut that and let's replace it with this one here. And then I'll say does not equal blank. So that means that there is always going to be a user agent. And looking at our notes, we did note down that PowerShell established an outbound communication towards this public IP address. So I am going to add that here as a filter where remote IP equals. Let's paste that in and take a look. So there were 2 connections, one at 419 and one at 632.26, going to the same IP and same port. Looking at the additional fields, we do see a URI of mainattack.ps1, and this is the user agent. However, if we take a look at the status code though, we do see a 404. So this was a failed download. If we take a look at the next event, this time around, we do see a status code of 200. And this is when they downloaded mimikatz.exe. The user agent here is Microsoft-Crypto API. And if we take a look, I think that is about it.
So if we go back over to the flag, it mentions after disabling security controls on contractor PC1. So after that, if we take a look again for the first event, this occurred around 4/19/05. Although it did occur after disabling the security controls, it actually failed. The next one was successful. So I'm going to assume that this is the user agent. And that is correct. The next one is the staging ground. The attacker needed a place to store their malicious tool before execution. They used a specific folder path on MTS Contractor PC1 as their staging area, a location where they could rename files and organize their tools without raising immediate suspicion. What is the folder path of that directory? Well, the key here is to follow the chain of events. So we know that they went out and downloaded Mimikatz, but we don't know where that Mimikatz was stored. Once we identify where that Mimikatz was stored, that would be the flag for this particular question. And whenever a file is downloaded to disk, you should see an event called file created under the device file events table. And that is where I'm going to look next. So scrolling up under device file events, take note of the time. This occurred around 6:32. So let's change this to 6:32. Or actually, you know what? Let's just change this to 6:20. Where device name contains MTS-contractor PC1. And we know that the file name is actually Mimikatz. So let's see that. And there are no files found. That's okay. Maybe it was renamed to something else. And actually, no, it's right here. Did I spell it wrong? Oh, that is my bad. Where file name ends with, so that is incorrect. It is actually contains. There you go. And the folder path of interest, it is C Windows temp TMP 121235. That is where they stored the Mimikatz binary and is likely where they are going to be hosting or staging all of their tools. Perfect. So I'll add some of this into my notes. Staging directory, Mimikatz downloaded here. All right, let's move on to the next one, which is persistence in disguise. It says the attacker created two scheduled tasks on MTS Contractor PC1 that masquerades as legitimate services, but actually executes a low bin process that you identified earlier. Identify the names of both scheduled tasks the attacker created for persistence. And it has a note, do not include any backslashes. We only want the name of the scheduled task. For example, scheduled task 1, comma, space, scheduled task 2. Well, to find scheduled task, we want to take a look into device events. And if we go back and comment out the action type and do a summarize count by, and I actually need to comment out the additional fields. There you go. If we take a look under the available action types, we can see that there is a scheduled task updated, there is a scheduled task deleted, and a scheduled task created. This is the one that we want. So say where action type equals scheduled task created. And let's comment out the summarize. And here we go. So there are actually 6 scheduled tasks that were created. And if we take a look at the first 2, it is OneDrive standalone update. Now, if we click into it and look at the triggers, we can see if it is malicious or not. It is instructed to run the OneDrive standalone updater.exe that is located under the local app data, Microsoft OneDrive. Now, is that malicious? Maybe, maybe not. But what we're trying to identify is a low bin process. And OneDrive standalone updater.exe doesn't fall under that criteria. If we go into the second event, again, hover over the trigger, we see another one saying OneDrive launcher.exe. Again, not a low bin process that we identified earlier. What we identified earlier was actually PowerShell. So if we click on the third event, now we can see that, hey, it is referencing PowerShell.exe, which is the one that we saw earlier. And we can see that it is instructed to start the process of C:\users public Microsoft Edge update.exe. So this is one of the scheduled tasks that we're interested in. So I'll go ahead and copy the name, paste that in here, comma, space, and let's continue looking. So the next event here, it is called Microsoft Edge Update Task Machine UA. Highlight over the trigger, and it is the same thing. It is referencing our low bin of interest. So that is our second scheduled task. Paste that in and hit submit. Correct. Now we do see an additional 2 scheduled tasks here that occurred at 6:42:44. But before we take a look into them, let me go ahead and put this into our notes. Scheduled task created. And let's just say 2 scheduled tasks created. So one of the name is Google Update Task Machine Core. And the other one is Microsoft Edge Update Task Machine. They are both instructed to run PowerShell with the same argument, essentially running the Microsoft Edge update.exe. And then we get 2 additional scheduled tasks. So this one is called System Health Monitor. And if we highlight over the trigger, it is running under C users public Sage Tax Tools with an executable file name called servicehost_update.exe. That is quite interesting. We also have another one called QuickBooks Sync. And this is running under C users administrator app data roaming QuickBooks Sync QuickBooks_sync.exe. So these are likely an additional persistence mechanism that the attacker had created. 2 schedule task created, system health monitor, and that executes service host update.exe. And then the other one is QuickBooks Sync, and this executes QuickBooks_sync.exe. Cool. Going to the next one, the Silent Watcher. The attacker deployed an additional persistence mechanism that executes malicious PowerShell code every 5 minutes to beacon back to their command and control server. This method is more covert than common persistence and triggers based on system events. Find the consumer name of this persistence mechanism. The hint right here is consumer name. For those that aren't aware, you can type in consumer name persistence. And if we scroll down, we can eventually find WMI persistence found, or a blog saying detecting and removing an attacker's WMI persistence. So with that hint, we can then filter even more for WMI. And now we actually get information pertaining this particular persistence mechanism. And if we scroll down, it says ultimately there are 2 components that define WMI event subscriptions. The first one is WMI event filters, and the next is WMI event consumer. A WMI event consumer is responsible for specifying the action or response to be taken when a WMI event occurs. So we need to find the WMI event consumer name. Well, similar to what we've done, why don't we take a look at the action types that are available to us and see if there's anything for WMI related. And yeah, there is actually a WMI bind event filter to consumer. Let's go ahead and filter for that. So WMI bind event filter to consumer. And there you go. There is one event. So let me comment out the summarize count and click into the additional fields. And here we have the consumer name called Windows System Health Consumer. But what exactly does this do? Well, if we go over to possible cause, we get a bunch of information here. What I want you to take a look at is the command line event consumer. You can see that PowerShell is being spawned, and it does that start process again that we identified earlier, where it's starting the process of Microsoft Edge update.exe under the C users public directory. So we know that this, in fact, is actually another persistence mechanism, where the consumer name, again, is Windows System Health Consumer. So I'll copy that, paste that in here. And let me remove all of that. There you go. Perfect. And before moving on, I will throw this into our notes. So this happened at 6:16:38. Ooh, the same time when our scheduled task was created. WMI consumer persistence. This was called Windows, what was it? System Health Consumer. Okay, on to the next. The extraction point. After logging into the domain controller, the attacker needed a location to organize their tools tools/files and prepare for the next phase of their operation. They chose a specific directory path to stage their activities. What is the full directory path where the attacker staged their tools/files on the domain controller? Now that I think about it, I kind of gave this question away. So if you recall, under the additional asset compromised, I did put in a question saying, what is the name of that additional asset? Well, if somebody went ahead and clicked on the extraction point, they would see domain controller, and then they would get a hint that, hey, it is likely that the attacker compromised the domain controller. So that is how you can get the answer to the additional asset compromised by reading the other questions. Heading over to our advanced hunting, I am actually going to check for the same MO that they did for the MTS contractor PC1. If you recall, under the device file events, the attacker downloaded Mimikatz onto this computer. So what we can do is search and maybe see if there was any Mimikatz downloaded on the DC. And in this case, there actually was. There was a file created for Mimikatz under the folder path of C Windows Temp TMP 819759. So this right here is different than the one on our contractor PC1. And what this tells me is that this is likely the folder path or directory of where the attacker is staging their tools. So I'll paste that in here, and that is correct. This occurred at 7:35:52. 7:35:52. Mimikatz created on MTS-DC under the file path of C Windows Temp TMP 819759. And we'll go on to the next one. Shadow operations. The attacker executed a command on the domain controller that created a snapshot of critical system data, which is a technique commonly used to access locked files and extract sensitive information while the system remains operational. What executable did the attacker use to perform this operation? And if we're not entirely sure how to proceed, or we're not sure what kind of executable can perform this function, we could just perform a Google search. What process can create a snapshot of locked files? And AI is saying the volume shadow copy service is the primary process used in Windows to create a snapshot of locked files. Perfect. So what is the volume shadow copy service? And then I'll just say process, and let's click into Microsoft's documentation. If we scroll all the way down here, we can see that there are tools. So the first one is Disk Shadow, and this allows you to manage all the hardware and software snapshots that you have on a system. VSS Admin is used to create, delete, and list information about shadow copies. And learning that, it is likely VSS Admin is the one that we want. Going back over to our XDR, let's go into device process events, and then I'll just say where process command line has any VSS admin. Does that show up anything? And it does. Nice. So under our process command line, we do see VSS admin list shadows, but it doesn't really say anything about create. Maybe it is hiding under our device events. So I'll change this to MTS-DC, comment out the action type. Let's just say additional fields contains VSS admin. We do see 2 hits, and there you go. The first event is VSS admin create shadow. This occurred at 8:05:43. 8:05:43. So VSS admin create shadow for =C:. I'll say on MTS-DC. And then they did a delete shadows. Okay, this occurred on, after they exfiltrated the data. So October 7th, 2025, 8:16:05 a.m. Attacker deleted shadows using VSS admin. All right, so that means the executable is vssadmin.exe, and that's correct. Next is the crown jewels. The attacker extracted a critical database file from the domain controller that contains highly sensitive credential information for the entire Active Directory environment. What is the exact command that the attacker used? For those that don't know, The sensitive database that contains information about the entire Active Directory environment is called ntds.dit. So ntds.dit. And here it mentions that this is the database for Active Directory domain services. What that means is that we can then just search for device process events where the command line contains or has any ntds.dit. We don't find anything? Okay, what if I do contains? I'm pretty sure I'm not going to see anything here either, but just in case. Yeah, okay. What about device events? Where additional fields contains ntds.dit? Okay, what if I search up just ntds under the device process events? Aha, so I do see two events. I am curious, do I see anything under the device event table? If I remove .dit, I only see one event, okay? And this doesn't really tell me anything. So let me go back over to device process events here. And at 8:05:46, the attacker ran ntdsutil.exe, where it extracted the ntds database over to c/temp directory. Very cool. I'm going to copy the process command line and paste that in here. Do take note of the time. This happened at 8:05:46. 8:05:46. ntdsutil was used to extract ntds.dit and placed it under c:\temp. Erasing the trail. The attacker attempted to cover their tracks by removing forensic evidence from the domain controller. They systematically wiped multiple logs that would have recorded their activities. List the 3 event log names the attacker cleared. And there is a flag format, so event log 1, space event log 2, space event log 3. Similar to what we did for the service that was stopped, we used the device events table. So that is what I'm going to be using. Comment out the additional fields. Let's do a summarize count by action type and see what is available to us. There is the PowerShell command. I am going to search for that and see what we can find. So there are 163 events. Let me go back and uncomment my project. Now the attacker attempted to cover their tracks. So it is likely they did this after exfiltrating their data. So around 8:11 or after 8:11. Scrolling down all the way to 8:11, so right here, 8:13:02, we can see, oh, right here, 8:16:01, WEVT util CL for clear, security, system, and application. So those are the 3 event logs that they cleared. Security, what was it, system, and application. Perfect. And this occurred at 8:16. 8:16:01. Attacker cleared event log, security, application, system. And finally, we have command history vanished. As a final cleanup step, the attacker removed a file that stores a record of all PowerShell commands executed in previous sessions, eliminating evidence of their interactive activities on the domain controller. What is the full file path, including the file name and extension that the attacker deleted? A file that stores PowerShell commands. This is the PowerShell console host file. And if we just scroll down a bit, we can see that there is a delete history path and a clear history happening around 8:16:05. So this right here is just removing all of the PowerShell commands. But what we are trying to identify is the full file path and file name. And immediately I'm thinking about 2 different tables. The first one is the device process events. Perhaps the process command line actually captures the evidence of deleting that file, or device file events, where we can see a file modification and or deletion of that particular PowerShell console host file. I am going to take a look into device file events for now, and I'll say where file name contains console host. I wonder if it's one word. Yeah, okay, cool. Console host _ history. And this happened at 8:16:05. File deleted, console host history. The full file path is right here. C users, administrator, app data, roaming, Microsoft, Windows, PowerShell, PS readline, console host underscore history.txt. Copy all that out and paste that in here. And that is the advanced track. The last and final flag is our bonus flag, called the encoded escape. The attacker used an unconventional method to exfiltrate credentials from the compromised environment. What account and hash combination was transmitted during this operation? So something was exfiltrated, and I need to identify what that something is. But before we do that, let me go back and put in my notes for the console history. 8/16/05. So same time when the attacker deleted the shadows using VSS admin. Attacker deleted console host underscore history.txt. Now I need to find the exfiltration. Because we have a timeline of events, I am going to filter from 8:10 up until, let's just do 8:20, because I believe the attacker would have exfiltrated data during this time frame. Now, of course, they can obviously exfiltrate data before. However, I do want to just focus on this time frame for now. If I can't find anything, then I'll backtrack and do some more investigation. And I'll take a look under the device network events because it is exfiltrating data. I'll say where device name contains MTS-DC. For the user agent, I'm not going to put that in yet, so I'll go ahead and comment that out. And the remote IP as well, I'll comment that out too. But the time, I am going to change this to 8:10 up until 8:20. Did I say 8:20? Yeah, 8:20. Okay, so we do have our file.io that we identified before. And then the other ones are going towards Microsoft. And yeah, it's just a service host. Doesn't seem to be anything interesting. Okay, what about device events? So change the time again, 8:10. Let's do 8:20. Comment out the action type. And we have 50 events. What we're trying to find is exfiltration. So we do see a lot of compression here. So compress archive. There's the file.io, the starting of the Microsoft Edge update.exe process, the clearing of our security event log, system, and application, along with our VSS delete shadows. And I think that's about it. But these are under the additional fields. So what if I remove my project and let's try that out. Okay, scrolling to the right, we don't really see too much. There's DNS, but that is normal for our domain controller. Okay, let's go into device process events. Change the time, 8:10. And I'm going to filter out the process command line because we don't care about NTDS right now. And what is this? 8:11:01 a.m. It's performing an NS lookup to a Microsoft domain. That is interesting. I'm going to open up CyberChef to see if this is a base 64. And there you go. We get an output of KRBTGT, which is the Kerberos TGT account, with the hash itself. Now that is an interesting technique, right? Because if we take a look and search up NSLOOKUP exfiltration, under Elastic, we get potential DNS tunneling via NSLOOKUP. And looking at the investigation guide, it says attackers can abuse existing network rules that allow DNS communication with external resources to use the protocol as their command and control and or exfiltration channel. DNS queries can be used to infiltrate data such as commands to be run, malicious files, and etc. It's also used for exfiltration since queries can be used to send data to the attacker-controlled DNS server. Now, do keep in mind that this is a simulated CTF environment and for educational purposes. And why I am mentioning that is because typically you would see a domain that is controlled by an attacker rather than Microsoft.com. For example, you might see this weird base64.evil.com. or whatever domain that the attacker is controlling. That way they can receive this query and actually understand it. But what we wanted to show you here is that it is possible for DNS tunneling for exfiltration and or communication towards a command and control server, which is why I put this under a bonus question. So hopefully that was something interesting and pretty cool that you learned. I am going to copy out this KRBTGT account, paste that in here and submit. And just like that, we have completed our first Capture the Flag event for the MyDFIR SOC community. For those that participated in the CTF, I honestly hope that this was a fun experience. And those that didn't have the opportunity to participate, there is always next month. And I hope to see you all there.